Hello everyone, welcome to today's lecture. So in today's lecture, we will study the theory portion of straight lines. Okay. So in this class, we will study first start with the concept of a straight line. After that, we will move to the various forms of equations of a line. After that, we will discuss that if we have two lines, then we have to calculate the angle between two lines. After that, we will discuss the conditions for the concurrence of the three lines, right? If three lines is meeting at a particular point, then what will be the conditions that the three lines will be concurrent at a given point, right? Next, we will discuss about the distance of a point from a line, right? If we have a line and we have another point, then we have to basically calculate the distance of that point from the line, right? After that, we will see some important results of a straight line. After that, we will discuss equation of internal and external bisectors of angle between two lines, right? If two lines are intersecting at a point, and suppose we have to draw angle bisector of the angle between the two lines. Then there can be two angle bisectors. One is internal and one is external, right? So in this part, we will discuss about both internal and external bisectors of the line, right? Angles. Now, after that, we will move to the equation of family of lines through the intersection of two given lines. Suppose we have two given lines and two lines, and these lines are intersecting at a given point, right? So we basically have to find a family of the straight lines passing through the point of intersection of that intersecting lines, right? After that, we will discuss some important properties of the straight line, right? So let's start. First, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Okay, let's start with the concept of straight line. So any curve is said to be a straight line if for any 2 points taken on the curve, each and every point on the line segment joining these 2 points lie on the curve, right? You can see this, that if we try to take any point on the line segment joining point A and B, then every point will lie on the given curve, right? And that curve will be called as straight line. Got it? Okay. Now the slope of line AB. Suppose we have a line having 2 points A and B, having the coordinates of A is x1 y1 and coordinates of B is x2 y2, right? So the slope of line AB will be m, which is equal to tan theta, and it can be calculated as y2 minus y1 upon x2 minus x1. Got it? So tan theta is equal to y2 minus y1 upon x2 minus x1, right? Now various forms of equations of a line. The equation of a line in general form can be written as ax plus by plus c is equal to 0, right? Clear? Now let's discuss slope intercept form. So we are given a straight line, you can see in the diagram. The equation of a line with slope m and making an intercept c, you can see that this line is making an intercept of c on y-axis, right? Therefore, we can write the equation of the straight line as y is equal to mx plus c, right? Y is equal to mx plus c. Got it? Second, point slope form. So the equation of a line which passes through the point x1, y1, right, and has slope m is y minus y1 is equal to m times x minus x1, right? Y minus y1 is equal to m times x minus x1. Got it? So it is basically point slope form. Got it? Okay, so let's move to the next form, which is 2-point form. You can see this, we have a straight line having p1 as coordinate x1 y1 and p2 as coordinate x2 y2, right? Suppose we have any coordinate p which lie on the line which is xy. So we can write the equation in 2-point form as the equation of the line passing through 2 points x1 y1 and x2 y2 is y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1, right? X minus x1. So now intercept form of a line can be written as, you can see this diagram, that is a straight line L is making an intercept of A with x-axis and intercept of B with y-axis, right? Therefore, the equation of a line which cuts off intercept A and B respectively from x and y-axis are, x and y-axis is basically x upon A plus y upon B is equal to 1, right? X upon A plus y upon B is equal to 1. Got it? Now, normal or perpendicular form. You can see in the diagram that we have a line L, right, which is suppose at a distance L from the origin, clear, and perpendicular to the given line. Therefore, the equation of the straight line upon which the length of perpendicular from the origin is L. Length of perpendicular from the origin is L, and this perpendicular makes an angle alpha with the positive direction of x-axis, right? Clear? This perpendicular is basically making an angle alpha with positive direction of x-axis in the anti-clockwise sense. Therefore, the equation of line can be written as x cos alpha plus y sin alpha is equal to p, right? X cos alpha plus y sin alpha is equal to p, where alpha is between 0 to 2 pi, right? Alpha is between 0 to 2 pi. Got it? Next, general equation of a line to the normal form. Now, the general equation of a line is basically ax plus by plus c is equal to 0. Clear? General equation of a line can be written as ax plus by plus c equal to 0. Got it? Now, to reduce the general equation of a line to normal form, we first shift the constant terms on RHS and make it positive, right? What we will do, we will shift C. Here we have C as constant term, so we will shift this C to the other side, right hand side, clear? And make it positive. If it is not so, then divide both sides by, right? We will divide both sides by root over coefficient of x square plus coefficient of y square, right? So you can see this, we can represent the given general equation of a line as what we have done. We basically keep the c on the other side, right hand side, clear, and divide the both sides by coefficient of root over coefficient of a square plus coefficient of b square, right? Coefficient of root over coefficient of x square plus coefficient of y square, right? You can see this coefficient of x is basically a here and coefficient of y is basically b here, right? So now we will divide it by a upon root over a square plus b square into x plus b upon root over a square plus b square into y is equal to negative of c upon root over a square plus b square. Got it? Now take cos alpha. You can take cos alpha as a upon root over a square plus b square and sin alpha as b upon root over a square plus b square. And p is equal to minus of c upon root over a square plus b square, which gives the required normal form, right? Which is basically in the normal form. Got it? Now, intersection of lines. We are given two lines. You can see this. We have two lines, a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So let the equation of lines be a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Then their point of intersection will be b1 c2 minus b2 c1 upon a1 b2 minus a2 b1 and c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. Got it? So this is basically the point of intersection, right? Now, distance form or parametric form. You can see this in the diagram. The equation of a straight line passing through the point x1, y1. We have a straight line which is passing through basically x1, y1 and making an angle theta with positive direction of x-axis, right? This line is making an angle theta with positive direction of x-axis. And what we have done, we have basically taken a point P, any point P whose coordinate is xy, which is at some distance r from the point A, which is x1, y1, right? Now the equation of this line can be written as x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to r, right? Where r is the distance of any point xy on the line from the point x1, y1. Got it? So in this way, you can represent the line in parametric form, right? Okay. So now let's see angle between two lines. We are given two lines. You can see this in figure. having slope m1 and m2, and the angle between the two lines is basically theta. Clear? Therefore, the acute angle theta between the lines having slope m1 and m2 is given by tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. Clear? So now condition of parallel lines. If two lines are given having slope m1 and m2, clear? So it will be parallel. Let m1 and m2 be slope of two lines, then the lines are parallel if m1 is equal to m2. Clear? Line will be parallel if m1 will be equal to m2. Got it? So equation of straight line parallel to ax plus by plus c equal to 0. Suppose we have a line which is ax plus by plus c equal to 0. Then if we have to draw any line which is parallel to this line ax plus by plus c equal to 0, then it can be taken as ax plus by plus lambda equal to 0. Clear? Right. So equation of line parallel to ax plus by plus c equal to 0 can be taken as ax plus by plus lambda equal to 0. You have to keep in mind, right? Got it? See, since slope is equal to m1 is equal to m2, and we know that slope is basically negative of x coefficient upon a y coefficient, right? So the x and y coefficients would be the same for a line to be parallel, right? Okay. Now, condition of perpendicular lines. In the figure, you can see this. We are given two lines which are perpendicular to each other, right? So let m1 and m2 be slope of two lines. Then the lines which are lines are perpendicular if and only if lines are perpendicular if m1 into m2 is equal to -1, right? That is the product of the slopes of the two lines will be equal to -1, right? So if one line is parallel to x-axis, then its perpendicular line is parallel to y-axis, right? It's very it's like a usual thing that if any line is parallel to x-axis, clear, obvious thing, then its perpendicular line will be parallel to y-axis. Got it? Next, equation of the line perpendicular to ax plus by plus c equal to 0 is taken as bx minus ay plus lambda equal to 0. You have to remember this. Clear? So suppose you have any line having equation ax plus by plus c equal to 0, then you can take any line which is perpendicular to the given ax plus by plus c equal to 0 as bx minus ay plus lambda equal to 0, right? Okay, so now the straight line ax plus by plus c equal to 0 and a dash x plus b dash y plus c dash equal to 0 are right angle if a dash plus b dash equal to 0. Clear? So the given straight lines are at right angle if a dash plus b dash should be equal to 0. Got it? Clear? Now the conditions of concurrence of three lines. We are given three lines, then three lines are said to be concurrent if they pass through a common point, right? Three lines are concurrent if they pass through a common point, that is, they meet at a point. If three lines are concurrent, then the point of intersection of two lines lies on the third line, right? Point of intersection of two lines will lie on the third line. Got it? So the lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 and a3x plus b3y plus c3 equal to 0 are concurrent if and only if determinant value of a1 b1 c1 a2 b2 c2 and a3 b3 c3 is equal to 0. This is the required condition of concurrence of three lines, right? This is the required condition of concurrence of three lines. Got it? Okay. Now distance of a point from a line. See, in this diagram you can see this. We are given a line and we are given a point, the coordinate of which is basically x1 and y1. So we basically have to find the distance of the point P from the line ax plus by plus c equal to 0. So the length of perpendicular is basically the actual distance, right? Therefore, the distance of the point P from the line can be also said as the length of perpendicular from point P x1 y1 to a line ax plus by plus c equal to 0. Clear? Therefore, the length of perpendicular will be modulus of absolute value of ax1 plus by1 plus c upon root over a square plus b square, right? Got it? Now, the distance between two parallel lines. See, in this figure you can see this. we are given two lines, right, which is parallel to each other. Clear? So it can be written as ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0. Clear? And distance between them is suppose d. Right? Therefore, the distance d can be calculated as distance between two parallel lines ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 is absolute value of c2 minus c1 upon root over a square plus b square. Right? Absolute value of c2 minus c1 upon root over a square plus b square. Got it? Clear? Now let's see some important results. The foot of perpendicular HK from x1 y1 to the line ax plus by plus c equal to 0 is given by. We basically have to calculate the foot of perpendicular, so it can be given by this equation h minus x1 upon a is equal to k minus y1 upon b is equal to negative of a x1 plus by1 plus c upon a square plus b square, where h and k is basically the foot of perpendicular from x1 y1, right? Now the foot of perpendicular from AB on x equal to y or x minus y equal to 0 is a plus b by 2 and a plus b by 2, right? Foot of perpendicular from AB on x equal to y or x minus y equal to 0 is a plus b by 2 and a plus b by 2, right? Now the foot of perpendicular from AB on x plus y equal to 0 is a minus b by 2 and b minus a by 2. Clear? X plus y equal to 0 or x equal to minus y or y equal to minus x. So the foot of perpendicular from AB on the line y equal to minus x is a minus b by 2 and b minus a by 2. Got it? Now the image HK from x1 y1 with respect to the mirror, with respect to the line mirror ax plus by plus c equal to 0 is given by h minus x1 by a is equal to k minus y1 by b is equal to minus of 2 ax1 plus by1 plus c upon a square plus b square. Got it? So image HK from x1 y1 is basically h minus x1 upon a is equal to k minus y1 upon b is equal to negative 2 into ax1 plus by1 plus c upon a square plus b square. Now the area of parallelogram formed by two lines, right? Since it is a parallelogram, then opposite sides, the opposite sides are basically parallel. Therefore, two lines of which should be parallel, pair of two lines should be the parallel, right? So see, we are given the equation of four lines, which are a1x plus b1y plus c1 equal to 0. Second one is a1x plus b1y plus d1 equal to 0. You can see this. The coefficient of x and y of these both two lines are basically same. So this is parallel. And next line is a2x plus b2y plus c2 equal to 0. And next one is a2x plus b2y plus d2 equal to 0. And these two lines are basically parallel. Therefore, the area of parallelogram can be calculated as absolute value of d1 minus c1 into d2 minus c2 upon a1 b2 minus a2 b1, right? A1 b2 minus a2 b1. Got it? So you can easily calculate the area of the parallelogram, right? Next, equation of internal and external bisectors of angle between two lines. See, you can see this. We are given two lines which is intersecting at some point. So we can draw bisectors. So see, a complete line, angle bisector at acute angle, right? And angle bisector at obtuse angle. You can see this in the figure. Therefore, the bisectors of the angles between two straight lines are the locus of a point which is basically equidistant from the two lines, right? The bisectors are basically equidistant from the two lines. The equation of the bisector of the angle between the lines are, we have two lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, right? Therefore, the equation of bisector is basically a1x plus b1y plus c1 upon root over a1 square plus b1 square is equal to plus minus a2x plus b2y plus c2 upon root over a2 square plus b2 square. Now where if a1 a2 plus b1 b2 should be greater than, it is greater than 0, then the positive sign for obtuse angle and negative sign for acute angle, right? And if a1 a2 plus b1 b2 is less than 0, then negative sign for obtuse angle and positive sign for acute angle, right? Negative sign should be for obtuse angle and positive sign should be for acute angle, right? Now next one, equation of family of lines through the intersection of two given lines. The equation of family of lines passing through the intersection of the lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 is, we are given two lines and we basically have to find the equation of family of lines passing through the point of intersection of these two lines, right? So it will be equal to a1x plus b1y plus c1 plus lambda times a2x plus b2y plus c2 equal to 0, where lambda is a parameter, right? Where lambda is a parameter. Got it? Now next, let's see some important properties. The position of a point x1, y1 and x2, y2 relative to the line ax plus by plus c equal to 0 is, see, we are given a line, and we basically have to find the position of some point, suppose p x1 y1 or q x2 y2, with respect to this line. So if ax1 plus by1 plus c upon ax2 plus by2 plus c greater than 0, then the points lie on the same side of the line, right? Clear? And if ax1 plus by1 plus c upon ax2 plus by2 plus c less than 0, then the points will lie on the opposite side, right? You have to remember these two conditions. Got it? Second, the equation of straight lines which pass through the given point x1, y1 and make a given angle alpha with the given straight line y is equal to mx plus c are can be calculated as y minus y1 is equal to m plus minus tan alpha upon 1 minus plus tan alpha into x minus x1. You can easily observe that if you will in the numerator, if you will take plus sign, then in the denominator you will have to take negative sign, and in the numerator if you will take negative sign, then in the denominator you will have to take positive sign. Clear? Okay. So let's see the summary of this chapter, what we have discussed till now. So we have discussed the concept of straight line, in which we have seen any curve is said to be a straight line if for any 2 points taken on the curve, each and every point on the line segment joining these 2 points lie on the curve, right? Now various forms of equation of a line, in which we have seen the equation of a line in the general form can be written as ax plus by plus c equal to 0. Now various forms of equation of line, we have seen the normal and perpendicular form, in which different forms we have seen: intercept form, point form, 2-point form, right? In which one important part was normal or perpendicular form, right? In which we had explained that the equation of the straight line upon which the length of perpendicular from the origin is p, and the perpendicular makes an angle alpha with positive direction of x-axis in anti-clockwise sense can be written as a cos alpha plus y sin alpha is equal to p, where alpha will be between 0 to 2 pi, right? And here cos alpha is basically a upon root over a square plus b square, and sin alpha is b upon root over a square plus b square, and p is negative c upon root over a square plus b square. Clear? Now after that we had seen the angle between two lines, in which we have seen the acute angle theta between two lines having slopes m1 and m2 is given by tan theta, which can be calculated as absolute value of m2 minus m1 upon 1 plus m1 m2, right? After that, we have seen the conditions of concurrence of three lines. Three lines are said to be concurrent if they pass through a common point, that is, they meet at a point. Clear? Then these three lines are concurrent, right? After that, distance of a point from a line. We had seen distance of a point from the line. So the length of perpendicular from a point x1, y1 to a line ax plus by plus c equal to 0 is absolute value of ax1 plus by1 plus c upon root over a square plus b square. After that, we had seen some important results, in which one important result was the foot of perpendicular hk from x1, y1 to the line ax plus by plus c equal to 0 is given by h minus x1 upon a is equal to k minus y1 upon b is equal to minus of ax1 plus by1 plus c upon a square plus b square. After that, we have seen the equation of internal and external bisector of angles between two lines, in which we have seen the bisectors of the angles between two straight lines are the locus of a point which is equidistant from the two lines. The equation of the bisector of the angles between the lines, right? We have seen. So after that, we have seen the equation of family of lines through the intersection of the two given lines. Here, the equation of family of lines passing through the intersection of the lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 is a1x plus b1y plus c1 plus lambda times a2x plus b2y plus c2 equal to 0, where lambda is a parameter, right? Lambda is a parameter. Got it? After that, we have seen some important properties in which we have seen the position of a point x1 y1 and x2 y2 relative to the line ax plus by plus c equal to 0 can be uh, can be seen as if ax1 plus by1 plus c upon ax2 plus by2 plus c is greater than 0, then the points lie on the same side, and if ax1 plus by1 plus c upon ax2 plus by2 plus c less than 0, then the points lie on the opposite side, right? Okay, so in this way we have seen different concepts of the straight lines, right? Hope in the question part you will be able to apply the concepts, and hope you liked our lecture, right? Thank you so much.